Hey, quick update on the machine. It's alive. I can show you. As you can see, it goes left and right, front and the back, and up and down as well. The first impression on the machine is that it's really quiet when you move. In the previous Chinese one, it was made of aluminium, the whole construction, and when you were jogging, it was so noisy. Everything was going into vibrations, and yeah, it was really noisy. That one, it's so quiet. The only thing which you hear is actually the stepper. You don't really hear the machine. Here you can hear the ball screw, but that's it. And because my VFD was burnt, I cut everything by hand and on drop saw. $250 drop saw for wood, Ozita. Does the job pretty well. Yeah, and what the video is about. I found a horrible issue. I show you that, so you already know what's the issue. But the issue that thing, I mean, you can't see that's going anywhere. But when you put the dial indicator on, it moves. I think 100 microns one way and 100 microns the other way, and yeah, that kind of puzzled me for a while because I thought, holy shit, it's like that thing, it's moving, you know, or something is moving so much, and yeah, I was trying to figure it out. What maybe it's my construction, but turns out that my construction, when I put quite a lot of force, you know, left to right, it moves maybe I think 2 microns, so it's not much, and this all 100 microns comes from the lead screw, and that freaking mounting block, which is supposed to be backlash free. Turns out that's not, and it's a Chinese one on eBay. So I would recommend to never buy that thing on eBay if you care for any precision. Yeah, I found some SBS mounting blocks. It's a bk12 in the regular store, professional, let's say, and the price was 170 New Zealand dollars. Yeah, that actually cooled my enthusiasm quite a bit, because I think I already spent enough on the machine, and I was just trying to make it slightly better than the Chinese one, and yeah, spending $600 just for the mounting blocks. Eventually I will have to, but I don't really want to spend it now, and I guess eventually I will have to change the rails, bow screw, but that's eventually. If I'm gonna be kinda annoyed beyond the reason, then I will go and buy the good brand, I would say. Yeah, I guess I can't say that's complete, you know, rubbish, which it is, but when you do maybe woodwork or something like that, it's, I guess, just fine if you can live with the, you know, smaller tolerances, but this what's really important. It's not the precision with which you're gonna be cutting. It's the chatter on the spindle at the end, because if that thing moves and moves every possible way, then it introduces chatter, and you cannot go as deep or fast milling something, because the drill bit would be wandering, and you end up with a bad finish and broken bits and clogging and all sorts of disasters, and it won't be quiet either. Yeah, so maybe what I've done here, I made the z-axis out of an inch thick plate. Then I reused the old steppers. Those are NEMA 23 from this 60-64 what I'm saying, 60-40 or 40-60 Chinese CNC, and they seem to be working fine. I think I put some considerable weight on that thing, and it's lifting up and down, no problems, so I guess it would be good. Being so heavily motivated after hearing the price of the new mounting blocks, I think I'm gonna try to do something with it, and at the same time I'm gonna show what's inside of it. So I already removed the screws, and there's like a cover. I'm gonna get the camera closer. The interior looks like that, and it has this metal spacer, whatever. It looks like it's kind of hardened, and inside you have two bearings, which are the 6001Z, if you can see it. And I don't think those are the thrust bearings, those are the regular ones. And when that thing goes into the housing, it has this metal thing, and then on the other one, so that touches the center of the bearing, right, and it pushes it against that bearing. But the problem with this is that those bearings have a radial play. So it doesn't matter how tight you're gonna press that thing against, it won't make any difference, because both bearings will go back and forth. And the one solution which I found for now, which I hope it will work, I cut myself some really dense plastic washers, which I'm planning to put the bearing here, then the washer, and the other bearing. Geez, it's pretty hard to... Okay, it's in. And now, when I'm gonna screw that thing all together, and put the lead screw through, and I tighten this thing up, then the bearings are spaced, but there will be gap in between them. Okay, I'm gonna show you again. So when you have them like this, they are touching precisely. So the inside, it's the same diameter thickness as the outside. So that's why you have a play in them, because they are exactly same. But when I'm gonna space the outside from inside, and then tighten the centers, then the bearing's gonna be compressed in one bearing on one side, and on the other bearing on the other side. So that should eliminate all the backlash. And that should be a fix for it, I'm guessing. It's really cheap fix, I think, and I don't really know how long it will last, but on the other side, or the other hand, it's I'm not spending that much on you know, milling, so I'm not milling like, you know, 24/7. It's like more like an hour per 7 days. It's, yeah, mostly a prototyping, so I think it should last me for a few years, I guess. But yeah, I'm not entirely sure, and I'm really curious what's your opinion about it. And maybe you could recommend some good bearing blocks, mounting blocks, sorry. Just trying to feel it by hand. It's not very scientific, but I don't know, I think it should work. I think it will be quicker for me to replace the Z-axis, so I'm gonna test it first, so we can have something something conclusive. So I'm gonna lower this. I really like those steppers because they have this knob, so it's really handy. So I guess I have to screw the bearing blocks a bit better, but yep. So I can put all my force I want and it won't move. Yeah, so when you watch that thing, it's not really moving. But, and I would really like to be slightly more scientific and put some weight in it, to see precise difference before and after. But I guess I'm just gonna use my hand, and you can actually see that goes quite a lot. So we have around, it's 0, and it goes to 0, yeah, 100 microns wobble, which on the outside case it's 10, more or less. Yeah, so it's 10, but I think I haven't really screwed the Z well to the rails. Yeah, so I'm gonna undo this, put the modified bearing block, and show you the result. Okay, I replaced the mounting block with the, you know, changed one, and yeah, I'm gonna show you the results. Yeah, it seems to be working. So stop wobbling. If I put it down, it just goes like so. That's the y-axis, sorry, Z, the case. That thing, when I'm like hanging on that thing, which I weighed 80 kilograms, hanging, I guess it will be around 50, I would say. I'm putting quite a lot. So you can, it goes like 4 microns, 3, 4. I'm gonna do the same here, and it goes 10 microns. Yeah, so I guess it did, oh gee, oh my fingers. It did improve it. Just a simple piece of hard plastic. I think that would be all for this update. Please let me know if you wanna see something close up, or if you have any questions, ask, and I try to put it into next video, or answer in the comments, and I kind of hope you can also give me some hints on mounting blocks and all of the stuff, and maybe give me some data on your machines, you know, what are the tolerances and stuff like that. I would be really interested, and yeah, see you next time.